Welcome to Veera's classroom. In last video we have seen the basics of block diagram reduction. We have seen the rules which should be followed for the reduction of block diagram. So today we will see a block diagram reduction problem. This is the first problem we are going to see. So here they are asking us to find the value of C by R. We are supposed to reduce this block and find the value of C by R. So as you look at the diagram, you can see there is an input R and a transfer function G1, G2, G3 and a feedback function H1 and H2. So this diagram seems to become somewhat complex, but we will do it step by step and we will solve it in 2 to 3 steps. So first thing, whenever you are going to find something, find a question, you are supposed to find whether there is any transfer function that are present in series or parallel. So first thing we will see whether there is a series in parallel, and we do not find any series combination, but we have a parallel here. G2 and G3 are in parallel. According to the rules, what is the thing for parallel is it should be either added or subtracted according to the symbol that is present in the summing point. In summing point both the things are positive, so it is easily get added. So this parallel G2 and G3 will become converted as a single block as G2 plus G3. This is the first step, combining the parallel blocks G2 and G3. Now what is the second next step? We will check it out for again whether any other parallel and series. If there is no parallel and series, we will look for a feedback loop. We will check whether there is any feedback loop is present. If there is a feedback loop present, we will try to simplify that feedback loop. Here we have two feedback components H1 and H2. So since we have two feedback components, we will check out with a smaller feedback loop. When you see the diagram, you can find it out. G1 H2 is the smaller feedback loop and G2 G3 and H1 covers a larger area. So we will first consider this G1 H2 feedback loop. According to the feedback loop formula, it is C by R equal to G by 1 plus GH. If it is going to be a negative feedback, this formula suits. So it is negative feedback, so the formula is G1 by 1 plus G1 H2. So we will solve that feedback loop. So this feedback loop is solved here. Is G1 H2 is converted as G1 by 1 plus G1 H2. So we will replace this feedback loop in the main diagram and we will redraw the diagram again. So after redrawing the diagram, so we have a summing point at the bottom. That summing point can be separated into two. We have a rule called splitting of summing points. So in that rule, what happened is they have splitted the summing point into two different summing point. But here what we are going to do is we are going to remove the summing point and we are going to draw separate lines. So this summing point which is at the bottom near to H1 is separated. So when you are going to separate it, you will have two lines that is flowing from output to R and between G1 1 plus H1 G2 and G2 plus G3 to the feedback. So we have another smaller feedback loop. We can eliminate that feedback loop by using the same negative feedback loop formula. So here the transfer function value is G1 by 1 plus G1 H2 and the feedback loop value is 1. So the formula seems to be simple. So it is C by R equal to G1 by 1 plus G1 H2 divided by 1 plus 1 into G1 by 1 plus G1 H2. Here we do not have feedback component, so it is 1 into. So we will take some common simplification like LCM and we will cancel out the terms. So the final feedback loop answer is G1 divided by 1 plus G1 H2 plus G1. So we can replace this value as the feedback loop value here. Next step, we have another feedback loop. Before going into the feedback loop, you can find it out that two transfer functions G1 by 1 plus G1 H2 plus G1 and G2 plus G3 are in series. So if it is in series, we will just multiply those terms. So we will combine the blocks in series and we will write it as a single block and we have write it in step 5. So in step 5 it is G1 into G2 plus G3 divided by 1 plus G1 H2 plus G1. The feedback loop feedback element is H1. Now the final step is going to be eliminating this feedback loop. So this feedback loop is also a negative feedback. So instead of G, we have a large term here, that is G1 G2 plus G1 G3 divided by 1 plus G1 H2 plus G1, and instead of feedback element we have H1. So, we will substitute it, and we are supposed to take a LCM at the denominator. When you are going to take the LCM at the denominator, we have some cancellations. After that, we will get the value of C by R. So, the value of C by R is G1 G2 G1 G3 divided by 1 plus G1 H2 plus G1 plus G1 G2 H1 plus G1 G3 H1. So, this is the final answer for this problem. Thanks for watching this video. If you like this video, share it with your friends. Kindly subscribe the channel and click the bell icon for constant updates. Thank you.